Right, let's run through the rules for graphing rational functions, okay? The steps. Now, first of all, to find your vertical asymptotes, you just set the denominator equal to 0. Okay, remember, you can't divide by 0, so whatever you get for that, you can't have. If the graph can't touch that, that's the vertical asymptote. So denominator is equal to 0 for vertical asymptotes. Okay, and actually, I'm going to jump to point 3, because to find the x-intercepts, you'll set the numerator equal to 0. Okay, to find the zeros, the x-intercepts, you set the numerator equal to 0. Denominator equal to 0 for their vertical asymptotes, numerator equal to 0 for the x-intercepts. Okay. Back to point 2, horizontal asymptotes. Remember the rules? If it's one bigger exponent on the bottom, it's always y equals 0. If it's like an x squared over an x squared or an x cubed over an x cubed, the same exponent, it's just the leading coefficients. Okay, we'll do some examples, but remember the previous video on horizontal asymptotes. Finally, the y-intercept is just you setting all the x's equal to 0. Okay, and also point 5, if you want to, you find some more points. In other words, when x is 2, what's y? When x is 3, what's y? When x is negative 2, what's y? Okay, just to make it a little bit clearer. So let's have a look at an example. Okay, here we go. Now, straight away, I can see the horizontal asymptote rule for this. Look, it's a bigger exponent on the bottom by 1. This is y equals 0. So straight away, I know the horizontal asymptote, which is point 2 here probably. There is y equals 0. There you go. Y equals 0 is the horizontal asymptote. We've just done point 2. Okay? Out of order. Who cares? Now then, I can actually also clearly see, watch this. Let me make it a little bigger. Watch this. If I get rid of the x's, notice if x equals 0, that'll give me the y-intercept. X equals 0, y-intercept. Well, that is negative 1/2. Okay, look at that. Positive 3 over negative 6, that's negative 1/2. And I think that's down here. There you go, right here. The y-intercept is negative 1/2. So I've also done that one. Again, just out of order, but it's whatever seems easiest at the time. To me, the horizontal asymptote was easy. And let me just step back on this. Bring back the equation. Okay, so I just looked at that and I thought, well, I can see the horizontal asymptote. And the y-intercept looked easy. Positive 3 over negative 6. That was straightforward. Now the x-intercepts the zeros. Remember, this time, just set the numerator equal to 0. This will give you the x-intercepts. Okay, so take away 3, divide by 2. Where's my x-intercepts? Here we go. Negative 3 over 2. Okay, comma 0. That's my x-intercept. So I found that one. I found that one earlier. Y-intercept. The hardest one really is for this one is finding your vertical asymptotes, because that's doing this. Okay, set this equal to 0, denominator. That means factoring. You'll get these two parentheses, so x cannot be 2/3. Okay, which means the vertical asymptote is 2/3, and also x cannot be negative 3, which means the vertical asymptote is negative 3. So if I put all those together, okay, I would have something like this. Okay, so remember, my horizontal asymptote was 0. There we go, right through there. My vertical asymptotes were negative 3 and positive 2/3. If you want to go back, you can look at all this. Okay, what else did I have? I have my x-intercepts at negative 3 over 2 and my y-intercept at negative 1/2. Again, it's going back to all of this information here from this. So that's what I would have. Okay. This is how to draw it. Okay, so what you really want to do then is go back to looking at point 5 and maybe plot a few more points. But let's have a look at this. Okay, so when x equals 2, who knows? When x equals 2, I would put it back into this equation. Okay, and actually what I get is I get a positive answer. So because of that, I would end up drawing something like this, approximately like that. Okay. Because any point over this side was going to give me a positive answer. So I'm just drawing it as though it's going to approach the asymptotes, okay? Because it could be in this corner, this corner, this corner, or this corner. Turns out it was in this corner, okay? Now how about when x is, say, negative 4, somewhere over here? If x is negative 4, I'd put it back into the equation, okay? And I end up with a negative answer for y. So I know this is going to look like this, okay? Like that. It's always sometimes in between the asymptotes you're not too sure about. Well, look, it's going to cross the x-axis here and the y-axis here. Honestly, there's no other way to draw this if it approaches the vertical asymptotes than this. See that? There you go. Across the x-axis and the y-axis. So that's it. Now, if I go back to there, here it is. But if you want to, as I say, use a table, grab a few more points. But sometimes it comes fairly logic how you've got to draw it. Okay. Now, admittedly, for this corner and this corner, I had to try some values of x to see what the value of y was. And that gives me a better idea of how to graph this. Okay. So that's graphing that one. Again, that's the bare necessities. That's me filling everything in. Let's have a look at another one. Okay, again, straight away on this, I can see, look at this, 1x squared over 1x squared. The horizontal asymptote is y equals 1. Is it there? There it is. Look at that, y equals 1. Okay, because it's x squared over x squared. 1 over 1, 1. Again, the easy thing about this one is, look, I can see what the y-intercept is. If x equals 0, it's just negative 1 over negative 6, which is positive 1/6. Let's look at it down here. There it is, like that. Okay, so I've just done the horizontal asymptote and I've done the y-intercept. Okay, because they were visually they looked easy to me. Now to do the x-intercepts, okay, set the numerator equal to 0. To do the vertical asymptotes, set the denominator equal to 0. Okay. So this up here, it'll be a difference of squares, x plus 1, x minus 1. So negative 1 and positive 1 should be my x-intercepts. There they are. Okay, down here. X-intercepts. Again, I just set that equal to 0 and solved it. Difference of squares. Setting the denominator equal to 0, end up with these. So my vertical asymptotes are going to be negative 3 and positive 2. So again, if I did a very, very rough sketch of this, look at this. Just look at this. So vertical asymptote, sorry, horizontal asymptote at y equals 1. Okay, verticals at negative 3 and positive 2. Again, I'm just doing it very, very quickly. I'll show you the exact one in a moment. X-intercepts at negative 1 and positive 1, negative 1 and positive 1. Okay, y-intercept at positive 1/6, wasn't it? So down here, positive 1/6. So there. Oh, very, very, I mean, I'll just put it approximately there. Now looking at that, I bet you anything, that must be that then. There you go, look at that. That must be that in between. Okay, now finding out these corner pieces, where does it go? Now look, if you think about it, there's no more x-intercepts. Alright, I've used up all my x-intercepts. I can't draw, I'll get the black arrow here. I can't draw anything here because I'll end up crossing the x-axis, won't I? I can't draw anything here approaching the asymptotes because I'll cross the x-intercept. The x-axis. So what I think it's going to be is this. One there and one there. Okay, but okay, let's look at exact. So approximately that's what it might look like. But let's have a look at the actual answer. Okay, right, and here it is. So again, remember, here's my x-intercept at negative 1 and positive 1. Here, right here, is my y-intercept at 1/6. Again, this here. Approaching the asymptotes, and they say, but actually what happens here is, look, this is a magnification of this. This is actually crossing the horizontal asymptote because it can. It still has to approach the asymptote. Okay, again, this is approaching it but not touching it. Over here, approaching but not touching, approaching but not touching. This is crossed, but it will start to go back and approach the asymptote. I know it's kind of hard to figure out what's going on sometimes. But actually, you can actually, I mean, you can put it in your graphing calculator, or you can actually, again, use some numbers. In other words, if I put x equals 3 into the equation, okay, again, what is it, the equation? Into this, into all of this. If I put x equals 3 into all of this, I'll end up with a point here, okay, right here. Now, it's above 1, above this asymptote, okay? If I put x equals 5 in, apparently, it actually does come out to be 1. It actually does come out to be at this point that crosses the actual asymptote. If I put x equals 6 into the equation, I'll realize, okay, if I put 6 in, let's just try it. X equals 6. 36 take away 1 is 35. Okay, I'm putting 6 into the equation. 36, okay, yeah, plus 6 is 42. Take away, so that's 36. Now, can you see that? That's actually less than 1, isn't it? That's actually less than 1. So it must have come below here, kind of here. Can you see this here? Okay. So I know that's not always easy to do, but again, it comes from plotting a few more points. Okay. But that's the graph of that equation. Okay. Again, 4 steps. your vertical asymptotes, your horizontal asymptotes, your x-intercepts, your y-intercepts, and then importantly sometimes try a few more points to see what's going on. Okay?